Hi everyone, welcome to the session. My name is Uros Milanovic and I'm product manager working with Microsoft. Today we're going to talk about SQL Managed Instance and its service architecture. We're going to cover how this service has been created from bare metal to the PaaS offering. Let's quickly go through the agenda. First, we are going to remind about the core value props of the managed instance and what are the core pillars that SQL Managed Instance as a PaaS offering relies on. Then we will quickly go through the isolation levels that exist in SQL Managed Instance architecture. And after that, we will jump to the instance creation demo, where we will remind about the options that exist during instance creation and how to easily and quickly create your first managed instance. While managed instance is being created, we are going to jump under the hood and see how this process looks below and what actually happens during this process. After instance is created, we are going to see how the configuration and the instance that we got is mapping to the core pillars that we went through the beginning of this session. And at the very end, we will cover cloud elasticity and scalability and how to easily scale your instance and satisfy your increasing demand, no matter if that is due to service growth or some seasonality that your business has. Okay, let's jump to the overview of Azure SQL Managed Instance. So SQL Managed Instance is cloud-based service that combines the broadest SQL Server engine capabilities with the benefits of a fully managed platform. SQL Managed Instance has the highest compatibility level with the surface area of the on-prem SQL Server with almost full feature parity. On the other hand, SQL Managed Instance is platform as a service that is running completely isolated SQL Server deployed inside the customer subnet. What fully managed means is that platform is responsible for managing and maintaining your infrastructure. So let's quickly go over the most important aspects of SQL Managed Instance. It has the rich programmability surface that comes with built-in high availability, offering 4 nines uptime SLA. Besides this, SQL Managed Instance offers the highest level of security in the database world. You are getting the all benefits of the platform, like automated patching and version upgrades, but you're also covered with automated backups and built-in disaster recovery options. For the full overview of SQL Managed Instance, you can visit the link at the bottom of the slide and get familiar with the basic concepts that are present in the official documentation. Now, let's jump on the core pillars. First pillar of the SQL Managed Instance are PaaS benefits. With PaaS benefits, you don't have to bother with the hardware purchasing or management. So entire data center where you are deploying your SQL Managed Instance is at your disposal. After you create your managed instance, you don't have the overhead of managing underlying infrastructure, since the service is the one that does the managing of the hardware components, software and software components, and SQL Server. For all of this, you have automated patching and version upgrades, but also you get simple integration with other PaaS data services present in the Azure. Now, the second pillar that comes on top of the PaaS benefits is business continuity, as all the hardware, all the underlying infrastructure are coming with a guaranteed 4 nines uptime SLA. What it means is that you're getting the built-in high availability stack that guarantees the SLA mentioned above. But not only that your service is highly available and that you have the SLA guarantees, but your data is protected with automated backups, which are configurable with a single click. So not your the job of maintaining the infrastructure, of patching and upgrades is fully automated. And on the other hand, the backups of the data are fully automated, including full backups, differential backups, and log backups. If you need even higher level of security, not security, but the data durability, you can configure disaster recovery through geo-paired setup where two instances deployed in a geo-paired regions are connected and ensure the highest level of data durability, where in a case of any disaster or any incident in one region, you can quickly jump into another region where your data is already in sync. Now, the third pillar is security and compliance. So SQL Managed Instance is deployed in a customer VNet sitting in a fully isolated tenant environment. This means that you define the subnet and the networking component where your SQL Server is deployed. Second, your data is encrypted. If you don't want to manage that on your own, you can leave that to the system and rely on system managed data encryption, but you can also bring your own key and take into control the data encryption by your own key management. Then the third part is authentication and identities, where you can leverage the Azure Active Directory integration, Windows authentication for Azure AD principles. You can rely on system managed identities. You can use your own identities, but everything is configurable and up to you to decide if this will be system managed or you will take care of that. Lastly, you can integrate with various number of services like SQL auditing, Microsoft Defender for Cloud, or if you want to have the you want to create some customized solutions for auditing, you can simply stream all the logs into a storage container, into SQL, into Log Analytics, that is another Azure service, and build some custom solutions. The fourth pillar is the ease of management. So rich ecosystem of the tools, starting from the migration, where you can use data migration service to move from on-prem, to move from other cloud, and migrate your data to the managed instance. After your data is migrated, you can easily automate all the processes that you're taking care of through ARM, through APIs, through PowerShell, through CLI, through Terraform, or you can simply rely on the Azure portal with rich user experience, where you have a lot of single-click configurations available as part of the managed instance. The fresh new scenario that is becoming more and more popular is the hybrid setup, where you can easily connect your on-prem environment with SQL Managed Instance and have disaster recovery or read-only instance in the cloud, and we will see that on the later slides. Now, let's quickly go through the isolation. As we mentioned, there are two aspects of isolation. One is networking, and the second one is tenant level isolation. And what virtual network isolation means? So during deployment, when you're creating your instance, you provide the subnet where instance will be deployed. This subnet needs to satisfy certain rules. So you need to prepare it, or the system will prepare it during the instance creation. For this, there are already ready scripts that can be used. But if you don't want to bother with this, you can simply create empty subnet, select it during instance creation, and the deployment process will prepare that subnet. What is specific is that subnets that are used for SQL Managed Instance cannot be shared with other resources. So subnets that are eligible for instance deployment are the ones that are empty or that already contain SQL Managed Instances. Those subnets are delegated to the Managed Instance Resource Provider, ensuring that all the changes in the networking requirements and networking stack are automatically propagated to this subnet. This is called service-aided subnet configuration, and it is also present in the official documentation of the service. Now let's see what is tenant isolation. So as we mentioned, instance is deployed in the subnet that you specified. And what SQL Managed Instance actually is? It is a set of service components like storage, event hubs, Active Directory, Key Vault, couple of platform services that are managed on your behalf, forming one platform as a service offering. These platform services are hosted on a dedicated set of isolated virtual machines that run inside your subnet. So service components like storage, event hubs, Active Directory are hosted on a system managed subscription, and platform services are being hosted on a dedicated set of virtual machines that are deployed inside your subnet. These machines form a virtual cluster, and the virtual cluster is component that is visible to you, that is visible as Azure resource, and it serves as a placeholder, as a host for SQL managed instances. One virtual cluster can host multiple managed instances, and as the demand grows or is reducing, it gets shrinked or reduced based on the number of instances added in the subnet, as a result of scaling the instance, of removing instances. So virtual cluster is dynamic. It adds or removes the virtual machines that are forming it. And what is important is that these virtual machines are dedicated to your instance. So these instances are part of your subnet. You have your own tenant, and no other services are being present on these virtual machines. So they are fully dedicated to you. Now, let's jump to the demo of instance creation. Let's go through the configuration options that are available during instance creation. We will cover each of the tabs independently and go a bit into details of the options available. On the Basics tab, as the name says, we have some basic configurations that include subscription and the resource group per managed instance will be deployed. Then we need to provide the instance name that has to be unique worldwide. We select the region where instance will be deployed, and then we are configuring compute and the storage options. Let's enter and see what options are available. First, we are choosing the service tier. Service tier represents two different architectures that exist for SQL Managed Instance, and we will go through these architectures later in the presentation. After selecting the desired service tier or desired architecture, we then select the compute hardware that will power this architecture or this managed instance. The main difference of these hardware generations is amount of memory per vCore available, but there are more differences that can be checked in the official documentation page. We select how many vCores we want to have for our managed instance, how much memory, and then we can use the the discount option available for SQL Managed Instance that is called Azure Hybrid Benefit. This means that you can bring your SQL Server license that have software assurance applied and use them for your managed instance, avoiding the need to buy additional instances. Lastly, we are selecting the redundancy for the backup storage that will be used for storing the instance backups. There are three options available. They include locally redundant backup storage, where backups are replicated only within single region. Then we have zone redundant option, where backups are replicated within the same region but across multiple availability zones. And we have geo-redundant backups, where backup storage configuration, where backups are replicated to the geo-paired region. So your backups not only that are available in your region or in region where instance is deployed, but they're also available. They're also stored in the geo-paired region, and you can use geo-restore option to restore the databases from that backups in case of any issue with the region where instance is deployed. After that, we are selecting authentication option. There are three options available: use SQL authentication, use only Azure Active Directory authentication, or use both. And all of these options can be configured later. So you can change your hardware configuration, you can change your backup storage redundancy, you can change authentication methods available. What you cannot change out of the box is region and a subscription and resource group where your instance is deployed. After basic configuration, we are switching to the networking. As we mentioned, instance is deployed in the subnet specified by you. You can select the virtual network and subnet that is already created, or you can get new virtual network and subnet created as part of the instance deployment. What we mentioned that is specific for SQL Managed Instance is that subnet can used for managed instance deployments can contain only managed instances. So subnets that are ready and prepared for managed instance can contain already managed instances, which is marked with the icon, or you can use subnet that is empty and already prepared for the deployment. But what about if subnet is empty and not prepared? It will appear in other section, and you can use that subnet as well, and it will get automatically prepared during instance creation process. Subnets that already have some resource deployed inside cannot be used, and they're marked as invalid. After this, we need to configure some characteristics of our networking environment. Do we want to use proxy or a direct mode for connecting to managed instance? Do we want to have public endpoint disabled or enabled? And what is the minimum TLS version that can be used for connecting to the managed instance? Now, what about the security aspect? Microsoft Defender is the Azure or Microsoft service that covers multiple Azure resources, including SQL Managed Instance. So you can include this to protect your data and through vulnerability assessment and advanced threat protections. You can do it at the instance creation, or you can simply enable it later. Now, each resource has its own identity. With managed instance, you get system assigned identity, or you can configure your own, so user assigned identity. If you don't want to manage this identity and you want to have system assigned, it is on by default. Windows authentication is something that was recently launched, and for this purpose you need to have Azure Active Directory principals, which can be configured here. The last part is data encryption. You can select the way how your data wants to be encrypted, and it is always encrypted. If you don't specify your key, the system will have service managed key. But you can also bring your own if that is something that your project requires. Okay. Now, what are some additional settings? You can define the collation of the managed instance, the time zone of the or that is used at the instance level, and you can define the maintenance window. With maintenance window, you specify the time slot when system should do the maintenance of your instance, which includes system patching, SQL patching, networking maintenance, and so on. This doesn't mean that system will do this every day. This is just the slot that will be used once when something appears for the maintenance. If you don't want to have every day available for this, you can narrow the slots by using weekday configuration or weekend configuration. So this option enables you to narrow the time and the days within a week when deployments can be executed for your instance. And what is geo-replication? So geo-replication represents the option for synchronizing data between two instances deployed in two different regions. So that in case of any disaster issues or any problems within the primary region, you can simply fail over to your secondary region and continue using your data until your primary is not recovered. So with this, you need to simply specify what is the primary instance that will be used for the replication, and the instance will get deployed inside the same DNS zone as your primary, which is prerequisite for establishing the geo-replication between two instances. After assigning the tags, if there is need for assigning tags, we can proceed to review and create blade and validate the data and start the creation. As you can see, deploying managed instance is a long-running operation, and we will now go under the hood and see how this creation process looks like from the backend perspective. So, creating managed instance is a complex process that interacts with Azure Stack on multiple layers. It actually consists of multiple steps that are related to the resources that we already mentioned, like the storage, Azure Active Directory, and so on, and a lot of compute resources. So at the high level, virtual cluster that is customer visible resource is created as an independent resource. Virtual machines forming that virtual cluster will spawn up, a bunch of stuff is installed, and then Service Fabric gets installed. And as we mentioned, Service Fabric is there to ensure the high availability of the entire infrastructure. After that, storage for data and backups is being attached, and SQL processes and a lot of satellite processes that ensure that all PaaS capabilities are up and running are being installed. Let's do now a deep dive. So, virtual network and subnet are holders for virtual cluster. Virtual cluster consists of multiple virtual machines that form that virtual cluster. That virtual machines host different application types. And we have virtual machines hosting gateways, virtual machines hosting load balancers, and virtual machines hosting SQL. All these virtual machines can also contain additional satellite apps that are there to ensure PaaS capabilities. These virtual machines also have Service Fabric layer installed that provides the high availability stack in all service tiers present in SQL MI, and that are general purpose and business critical that we saw that are selected during instance creation. Now, what's the difference between general purpose and business critical? There are a lot of differences, but two main can be selected. First is about the storage. So general purpose service tier uses a remote storage for data and log files, where business critical relies on the local storage. That is why there is difference in like IO latency, in-memory OTP, and so on. The second part is how high availability is implemented in these service tiers, and the full difference between them can be seen in our documentation. And on the next slide, we will go and see more about the HA stack and compute and implementation from the compute side of those service tiers. Let's start with general purpose. So this is already familiar. Virtual cluster, service fabric, gateway virtual machines, load balancer virtual machines, and then we have the SQL virtual machines. So this virtual machine has attached SSD that is used for temp.db files. We have one machine that is primary, and we have some spare nodes that use as a secondaries. So they are not active, they're part of the cluster, up and running, waiting for the failover moment when primary is switched for current primary to some of the spare nodes. Now, what about data and log files? These are hosted on Azure Premium Storage with locally redundant configuration, and this primary communicates with this storage. In case of failover, the temp.db is spawned up on spare node, and storage is being reattached from one virtual machine to another. And this is how the high availability stack looks like in general purpose service tier. One additional storage that is used is storage for backup files. And we saw how during instance creation, redundancy of this storage can be configured to be locally redundant, zone redundant, or geo redundant. So separate storage accounts for data log files and for backup files. This is about general purpose. What about business critical? So same architecture at the beginning, general purpose. Virtual cluster, nodes for gateways, for load balancer, service fabric, but DB nodes are now forming always-on availability group. These nodes, virtual machines, have SSD for temp.db, data, and log files, and this data is synchronously replicated across all nodes. In case of failure of any node, there is spare node in the cluster that is sitting and waiting for signal to join this availability group, and data will be seeded to this node as well. So, as we can see, HA stack relies in general purpose on spare nodes that after failover are just being reattached to the remote storage, while in business critical, we have local storage and always on availability group for HA stack. What is same in these service tiers is that for the backups, the remote storage is used and its redundancy is configurable. Now, this slide shows the differences in architecture. But what may be confusing for this slide is virtual cluster built per service tier. Well, this is not the case. Virtual cluster is shared. All nodes are part of the one virtual cluster. And one instance of GP, for example, with it connected to the remote storage, one business critical with local storage, in both of them having their own backup storage files. So this is how architecture looks under the hood. And how is this visible for the customers from the resource perspective in Azure Portal, PowerShell, CLI? Well, you see one virtual cluster and you see one GP and one BC instance that you actually connect to and work with. Now, these machines are part of the virtual cluster, and these machines have their own addresses that are taken from the customer subnet or the subnet that is provided during instance creation. It is important to upfront determine subnet size depending on your need. how many instances you plan inside, do you plan to do the scaling operations of those instances, and so on. Why? Because only empty subnets can be resized. And if you come to the limit of the subnet, you need to take some additional actions. Each virtual machine inside the subnet takes one IP address. Number of managed instances that can be deployed in the subnet or virtual network depends on the size. And this is some basic formula that represents how many IP addresses general purpose and business critical instance takes. So Azure at the very start takes 5 IP addresses in each subnet no matter for what it will be used. So if you have subnet of size 64, the 5 will be dedicated to the Azure and 59 will be at your disposal. Virtual cluster then takes additional 6 addresses, and then each individual instance uses some additional addresses, which for GP makes in total 14, and for BC it totals 16. Note that this is the case when only one instance is deployed in the subnet. And what about scaling? What if you want to scale your instance? Well, then you need some additional addresses. So for example, if you want to scale general purpose instance, you would need additional 3 addresses, so temporarily doubling the size. That is why the minimum recommended size for the subnet used for instance deployment is 32 IP addresses. As we mentioned, temporarily, the additional addresses are required in case of scaling, vCore, scaling storage for business critical, switching one service tier to another, and so on. And later we will see also how this process looks like. Now, let's see how different management operations that can be executed on one or multiple managed instances impact the virtual cluster and this architecture that we went through. One of the benefits of the cloud is elasticity and scalability. So you can scale on demand at any point in time due to seasonality or the growth of your service, the growth of your customers, or you can simply adjust configurations like new hardware is out, you want to change the maintenance window being used, your networking department changed some configurations and you need to move from one subnet to another. So management operation that result with changes in the virtual cluster and require its expansion or shrinking are vCore scaling, storage scaling, but only in case of business critical service tier, changing the service tier, general purpose to business critical and vice versa, changing the hardware from standard to premium series, premium to standard series, and so on, changing maintenance window from one slot to another, and moving instance from one subnet to another. How these management operations look like actually? So this is virtual cluster that we already saw. It has one general purpose instance, one business critical instance. Let's say that we want to scale general purpose instance from 4 vCores to 8 vCores. What actually happens here? So new virtual machines are added to this virtual cluster, and this virtual cluster gets resized. Resize means that new machines are being added. After new machines are added, the pointer to the remote storage from the old primary to the newly added virtual machine is being changed. And this is one of the characteristics of general purpose service tier. The change of virtual calls will only result in reattaching the storage from the old machine to the new one. After the storage is reattached, the failover happens. So we switch from one virtual machine to another, saying that this virtual machine is now primary. And after this happens, the original virtual machines are being removed from the virtual cluster. So what is important to mention here? Adding new virtual machines operation takes some time. Spawning up new processes on this virtual machine, adding SF, and so on. But the actual downtime during this operation is measured in seconds, and it's only the moment when failover happens. All the rest of the time during the operation, the instance is available up and running. How this looks like from the business critical perspective. So in business critical case, we have local storage and we have always on availability group. When we scale, The new virtual machines are being added with their own SSD for 10 dB data long files as the first step. And then the second step is data seeding. So data from these virtual machines needs to be seeded, and not to only to one virtual machine, but to all replicas that are part of the availability group. When this operation comes close to the end, the failover happens, and we have the new primary with all the data that was already present on the previous machines. And pointer to the backup storage is changed. After all these steps are finished, the original virtual machines are being removed and virtual cluster is being downsized. So we remove all the virtual machines that are not used anymore. So as we can see, virtual cluster expands or shrinks based on the demand, based on the new instance add-ons, which would result with the same experience or as a result of the scaling operation. Now, when our instance is created and when we saw how this process looks like under the hood and what are the managed operations that impact virtual cluster and its behavior, let's see how this instance maps to the core pillars that we covered at the beginning of the session. So with basic configuration, by selecting service tier, by selecting the hardware, the size of our instance, we automatically got hardware dedicated for our instance and the infrastructure that is managed by the platform. Not only that this hardware is managed, but is also automatically maintained and patched through the entire stack, from the bottom and the compute layer up to the SQL. In case of any need for scaling, increasing the size of the instance, increasing number of instances, the entire data center and its compute is at your disposal for deploying new managed instances. All these instances come with built-in high availability by leveraging the capability of Service Fabric that is installed on the virtual machines forming the virtual cluster. This high availability stack provides the 4 nines uptime backed up with the SLA guarantees. And this SLA and this uptime applies for both service tier, general purpose and business critical. And as soon as our instance is created, as soon as that data starts to data appears on the instance, it is automatically backed up, including full diff and log backups. Instance is fully isolated through tenant isolation and through virtual network isolation, where subnet use for instance deployment is provided by you. Data is encrypted for the very beginning, and instance gets its own identity that can be used for integration with other services. When instance is created, you can connect to it through SSMS, ADS, or use data migration service to migrate your data from any source. And besides this, you can integrate through public and private endpoints with all other PaaS data services. You can further automate processes that you have repeating, like through ARM, API, PowerShell, CLI, Terraform, or you can use Azure Portal for like ad hoc operations and adjust anything that needs to be adjusted later. So what can be adjusted? Starting from Azure Active Directory, networking, enabling Microsoft Defender for Cloud, changing the way how data is encrypted, updating the identity, streaming data through diagnostic and logs. All these operations are supported as well as in Portal, so as in tools for the automation. So choose your own preferable way to adjust these settings. By adjusting these settings, you can further enhance the pillars that we saw. So, but you can further enhance data encryption by bringing your own key if you want to take over the management of the keys instead of letting service doing that. You can switch between Azure Active Directory authentication, SQL authentication, use Windows SOT, use Azure Active Directory principles. or you can enable Microsoft Defender, SQL auditing, and other security tools. Now, how can we enhance the backups? Well, each database is configurable in the terms what backups are stored and how long they are stored. So for each database hosted on managed instance, you can configure short-term retention from 1 to 35 days. But if there is need for longer retention of the backups, you can configure weekly, monthly, and yearly backups that are stored up to 10 years. And if you want to protect from regional disasters, you can leverage the benefit of GeoDR setup, which means that you deploy secondary instance in another region that is connected to the primary instance region A. And we saw during instance creation how you can assign specify that the instance you're creating is going to be the secondary. So you create secondary instance in geo-paired region and you have two instances, instance A and instance B. Then you establish the virtual network peering between virtual networks hosting those instances, or you can connect those VNets some other way like using gateways. And at the very end, you configure a failover group between these two instances. With this last step, data will start flowing from region A to region B. In case that region A goes down, your application or service connecting to the instance will start using the data from the region B. So in case that region A goes down, the failover automatically happens to region B, or you can at any moment manually do this failover for like testing purposes, or simply just using sometimes region B, sometimes region A. With this, our data protection is leveled up, and we have further did the setup of geo-paired instance and protected from disaster recovery. So it's very great to see how easily you can spawn up the second environment in another region in just a couple of clicks without any planning of the capacity, purchasing space, purchasing machines, and managing them. Now, what about the last box, the hybrid? Hybrid is new experience in SQL Managed Instance called Managed Instance Link. With this capability, you can connect your SQL server hosted on-prem or in any other cloud with SQL Managed Instance. SQL Managed Instance becomes a secondary that can be used as read-only replica or can be used for integrating with other Azure services hosted in Azure Cloud, like Power BI, machine learning, signups, and so on. So a bunch of new scenarios that now are unlocked with this hybrid setup. And with this, we have covered the last box in the matrix of managed instance capabilities organized into the core pillars. Some closing words. So in PaaS world, all compute-related operational management tasks are offloaded to the cloud provider. So you can fully shift your focus to your database and application development. You don't need to do any upfront planning or do any purchasing or maintaining because hardware from the data center is at your disposal. You can easily scale inside one region, or you can spread across the globe with just a couple of clicks. With SQL Managed Instance as a SQL PaaS offering, you're getting the most secure database in the cloud and almost 100% surface area compatibility. You're getting the built-in high availability with 4 nines uptime and SLA guarantees. And underlying infrastructure is managed for you and always being up to date through the entire stack. I hope that this presentation was useful for you, and thank you for your attention. I am happy to be here today and be able to present SQL Managed Instance product.